Hi, this is Involved Innovation YouTube channel. In this video we will see about how to connect to Esp32 through WebSocket, and then we will try to turn on the three lights. Here this is what we are going to see in this particular tutorial. Here Esp32 is the server. The client can be anything. Here I am using my mobile phone as the client, and through this client I am trying to connect through the Esp server, and then here I am trying to turn on red light or green light or blue light. Here all the communication happens through the WebSocket. Here first we will start with what is WebSocket. WebSocket is a computer communication protocol providing full duplex communication channels over a single TCP connection. The WebSocket works like this. First the client, here in this case the client can be our laptop or our mobile phone. Here the server is Esp32, and here in this case we are sending, the client sends the request to the server, and once the request is valid it sends back the handshake. Now the communication is established between the client and server. This communication is more like a bidirectional communication, so the client can send the data to the server and the server can send the data to the client. So the server will send the data. Whenever the data is available, it will start sending the information to client. Similarly, the client will send the information whenever there is an event triggered. So this is the WebSocket, and here we are going to connect three different LEDs to Esp32. So first we will see about how to connect to the LED. The LED has two terminals, one is positive and negative. Longer terminal is a positive one and the shorter one is the negative terminal. So here in this case we are connecting through the Esp32. Here I am using three different GPIO pins, that is 1, 2 and 3. Here I am connecting red to the GPIO pin 1, green to the GPIO pin 2 and then blue to the GPIO pin 3. For this particular project I am going to use the PlatformIO IDE. The PlatformIO IDE is a plugin in Visual Studio Code. So if you are not familiar with PlatformIO IDE or how to set up PlatformIO IDE in the Visual Studio Code, refer my video tutorial, the link of which I have given in the description. Here I have opened the empty project. To create a new PlatformIO project, click the PlatformIO and then click the home and then click open. In the home, click new project and then project name WebSocket. And then board, in my case I am using Esp32-S3-DevKitC-1. Here we need to select the framework as Arduino. I am just giving the default location. You can specify your own location if you want, and click finish. Once you click finish, it will create a boilerplate project and it will have everything starting from the PlatformIO INI and source directory, lib directory and then include directory. For this we have 5 different dependencies. The dependencies are Wi-Fi for Wi-Fi connectivity and FS, and then SPI FFS, and then we have ESP asynchronous TCP and then ESP asynchronous web server. We will add the library dependencies here. I will add the library dependency for TFT. So I already have this project in my GitHub repository. You can copy and paste the TFT_E SPI from my GitHub project to the library. Here I have copied and pasted the TFT_ESPA. Now we are done with our basic setup. Now we have added all the dependencies, and this is only optional. If you are not going to use any T-display monitor, you can use the serial to print all the console logs. First we will start with HTML files and CSS files and JavaScript files. We need this HTML files and the CSS files and JavaScript files because these files are the one which will be supplied from our web server. Here our web server is nothing but the Esp32. So the Esp32, whenever there is a client which connects to the server and when it goes through the route, so he will get the HTML page where it has the 3 checkboxes. And this will be provided by your web server. So you need to make sure you are creating the HTML file. So first I will start with a new folder. So this folder is a data folder, and here we will create a new file named index.html. And here in this index.html we will create 3 different checkboxes. So I have already created an index.html. I will just try to copy and paste this index.html here. I also created a CSS file, so we will copy and paste the CSS file as well. So for the CSS file I will create a new folder named CSS. So new file style.css, and then I will create another folder named script where I will paste all the JavaScript files. So in this case I will create a new file named socket.js. We'll go to the index.html. So in this case, first we have our title. The title is the one which will be displayed in the tab. So here we have also added the dependencies style.css. So here in this case, since the folder name is CSS, I am giving it as CSS. If you are creating a different folder name, you need to make sure you are changing this folder name here and then the file name here. And then I have created a container, and this container holds all the 3 checkboxes. We will see why we are adding this 3 state later in the video. So for now I will just try to remove this 3 states. And then here we have created an input. The input is checkbox type. And then here in the script we will add the socket.js. We will copy and paste the socket, and I will try to explain what is going on in the socket.js. Yeah, first we are using the window.location.hostname. Window.location.hostname is the current URL whatever the website is loading on. The target URL as the WebSocket WS protocol, and then we have our host name which we are getting from the browser. So here we are trying to invoke the onload function. So the onload function, it initializes a socket connection, and it has 3 methods: on open, on close, and on message. So this is send message. Whenever we want to send message through the WebSocket, so this is how we will send. We will try to add 3 different event listener, one for red, one for blue, and one for green. Here we are trying to get the red by the ID red. Here we have 3 different ID, one for red, one for green, and one for blue. This depicts the 3 LED LEDs. And we will add a event listener which is a change event listener. So whenever there is a change in the element red, we can able to see the red dot checked is on. If the red dot checked is on, then we will send the message red on. Here we are using this particular function which sends message in the WebSocket. If the red is checked, that means we are sending the message red on. If the red is unchecked, then we are sending the message red off. So here also we are sending blue on or blue off whenever the blue is checked or unchecked. So here we are sending green on whenever the green is checked, and green off whenever the green is unchecked. So now we will go to the main.cpp. This is the place where we will put all the web server code. So first we will add some dependencies. So already we have Arduino.h. We will add these dependencies. We need pin.config.h. So this pin.config.h is used by the LCD. So here in this case I am using tdisplay S3. In your case, if you are not using Esp32 which has an inbuilt display, you don't need this particular file. You can ignore this file. But in my case I need this. So I'm adding this pin.config.h. First we need to initialize the tft_espi. So I have created a new object tft. I need to define the constant. The 2 constant is constant char, and here we need to give our ssid. So ssid is Wi-Fi name. So you need to give your own Wi-Fi connection. So you need to create another constant char, and this is password password equal to, I'm just giving my password here. And then first you need to initialize async web server, and I am opening this in the port 80, and async WebSocket, this I'm giving it as ws. We have given this /ws in our socket.js. Next we will create a function to get the y coordinates for our tft. For this function we will initialize a new integer variable y equal to 0. So this function returns integer value and then get y-axis value, and here if y value is lesser than 140, then increment the y value and return the y equal to y less 16, else y equal to 16. If the y value is greater than 140, then we will start from the first line. So we will give it as y equal to 16 and then return void turn light on off, and this takes a single parameter. This single parameter is char star command. So we will use the string compare function. If the string compare command comma red underscore on equal to 0, if the command matches to red on, so this is what we have given in the socket.js. So if the red is on, we are giving this particular string red on. If the red is off, we are giving this particular string red off. So if red is on, then we need to call the digital write function. I will create constant here, constant int red pin equal to 1, green pin, blue pin equal to 3. Copy the red pin, comma, I. Now copy this again, and here we need to make sure we are giving it as else if, and here instead of on it must be off, and here instead of high it must be low. Now copy this command again. Now copy this complete if else block again. Here change this to else, and here this is green on, and here this is green off, and here instead of red pin this is green pin. Copy this green pin here and then paste it again. Now copy this green, paste it here. Now instead of green on, this must be blue on, and then here instead of green pin this must be blue pin, and this must be blue pin as well. So far so good. We have defined our main function. So this main function takes the command and it sets the pin to high or low based on the incoming command. And we will define our main function, which is on WebSocket event function, and this takes server, client, type, and then arguments and also data and length as the parameters. So here we have different types which can be incoming. So first we will create a switch type, case ws underscore event underscore connect. So in this case you can just print something in the serial connection, or you can use the TFT. So I am going to use the TFT here, tft.drawString, which takes 4 different attributes. One is the string. So here this is WebSocket event connect, and then the next one is the x-axis. The x-axis I am giving it as 0, and then the y-axis case I will give the function getY, which we have created, and then the text size as 2. So if you are not using any TFT board, if you want to print everything in the serial, you can use the serial command. Write the command such as serial.printf, and here you can print your string. So in my case, since I have the TFT board, I am printing everything in the TFT. So I will copy and paste this again. So this is WS event. Instead of connect, this is disconnect. And then I will add another case, which is event data. This is the important function. So AWS frame info star info equal to AWS frame info star argument, and then if info final, and here we will give and info is index equivalent to 0 and info len equal to length, then if info opcode equal to ws underscore text data and len equal to 0, the char star command equal to char star data, and then we need to call our turn light on off function here. We also can define another 2 different cases. I will keep this as dummy. You don't want to do anything here in this event. You can just add some logs information here, just if you want to debug. And I will create another function which is a not found function. So this will be invoked if there is a route which is called, and if there is any route which is not supported by this web server is getting called. So void not found async web server request send 404. So we are sending it as 404 and text plain, and then the string is not found. Now we will start with our setup function. So first, to make sure you are defining the pin. So here the 1 is the red, and then the 2 is green, and the 3 is the blue. If you are using the serial communication, you need to make sure you are opening the serial bond 115200, and then I will add some particular code to the TFT. I will begin the TFT and then I will set the rotation. So here this converts from portrait to landscape, so it will start printing everything as a landscape. And then I'm filling the screen with black color, and then the text is gold, and then I'm just giving the first string as connecting to, and then the SSID. So here we have already defined this SSID. Now we will add this code. First we will connect the Wi-Fi mode equal to Wi-Fi underscore STA, and then Wi-Fi begin. So here in this case SSID and the password. So here you are supplying the SSID in the password, and then next you are waiting for the connection to establish. Once the connection is established, we are validating here. So if the connection is established, then we are printing out it's connected. If there is some failure, we are trying to print the result. I will show how to debug this with the code which you are getting here. And then we are printing out the IP address. This is the IP address of the web server, nothing but the ESP32. So this is web address you need to connect. And then we are checking the SPAFFS. If the begin is true, then we are not doing anything. If the begin is false, then if there is any problem, we are printing out error message to our TFT board stating an error has occurred while mounting this PAFFS. And then we need to invoke the WebSocket, and then we need to add the handler, and we are adding the callback function to the WebSocket server. So in this case we have this here. So this is the function which we have already created, and this is that WS. So this is the WS which we have created. Now we will try to supply the HTML and the CSS and the JavaScript. Server.on. Here this is the empty route. If the route doesn't have any value, we are trying to render the index.html. So this will send the index.html, printing out requesting index page in our TFT. And then if you are trying to get the CSS, the route is css/style.css. And here we are printing out requesting style CSS, and then we are giving out the style.css. And then we are checking the socket.js, and if the socket.js is the one which you are requesting for, then we are getting it from the data and we are giving it back to the client. And then we need to add server.onNotFound. So this we have already created. This is a function, and then server.begin. So since everything is happened asynchronously, we don't want to keep anything in the loop function. Just I have restarted the Visual Studio Code, then it will get all the necessary dependencies. Now we can able to see all the necessary dependencies, and then here you can go to the individual functions. If you click this WS event connect, and then if you click this on, or if you click this send function, you can able to see it goes to the async web server request. So far so good. Now we will try to build this code. Click the stick button here. If you click the stick button, it will just try to build your application. If there is no typo, then I believe this code will run perfect. There is some error here. We need to return the value of y. I forgot to return the value of y here, so we will just rerun it again. So now the build is success. We can able to see the build success command here. Now we will try to upload this. So to upload, just go to PlatformIO, and here expand this one, and here click upload file system image. Once you are clicking the upload file system image, make sure you are clicking the boot button. So if you click upload file system image, then only the data folder will go inside ESP32. Now everything looks perfectly fine. So we got connected successfully. The first line gives the connecting to, and then the second line is our SSD, and the third line is the connected successfully, and the fourth line is the IP address. Now we can able to see the IP address. The IP address is 192.168.0.179. Now I have already opened. So now we'll refresh this connection. It is requesting the index page. Now everything's loaded fine. Now we can able to see the requesting index page, requesting style.css, requesting socket.js, and then WS event connect. And here also we can able to see everything loaded fine in our mobile browser. Now I can able to click the red, it turns on the red light, and I can turn on the green, and I can turn on the blue. Now everything looks fine, and here we will try to turn on the green light. So to turn on the green light, click the green. So now we will try to open this in the browser, 192.168.0.178 from the browser. Now we can able to see the green, whichever is reflecting here in the mobile phone, is not reflected correctly in the browser. It doesn't look for the initial state of each and every pin. To mitigate this, so we can create a processor function. So here in the processor function, we can get the digital wire pin input, and then we will supply this on load. So we will create a function named processor. Here first we will create a function named getPinState string getPinState int output if digital read is output return checked, and else return. Now we'll go to index.html, and in the index.html we will add 3 state. So for this I will add the red state here. To add a red state, percentage here inside that I need to add red state, and then similarly percentage green underscore state, and then percentage blue underscore state. This red state, green state, and blue state will be supplied to our main CPP, and then in return it will get whether it is checked or unchecked. So here if it is checked, here this value will be replaced with checked, which in turns on this light, and if the value is empty, then it won't turn on the light. Now we will create a function processor. I have already created this processor function. I will just copy and paste this. This takes the input var, and then it initializes the status as empty, and then here we are just trying to print the value on the TFT. If it is red state, then we are calling the get pin state with 1. So here instead of 1 we will give it as the red pin, and here instead of 2 we will give it as green pin, and here instead of 3 we will give it as blue pin. Now we have our red pin, green pin, and then blue pin, and there is a value red state, green state, and blue state. And if the value is red state, then we are calling the get pin with the pin 1. So if it will check what is the value of the GPIO pin 1. If the value of the GPIO pin is set, then it will give checked. If the value of GPIO pin 1 is not set, that means the light is not turned on, then it will give the empty string. So that means it will be not checked. Now we need to give this processor function here. So this false is a flag to show whether this is a downloadable file or not. So this is not downloadable, so here we are giving it as false. Given the processor function, we'll build PlatformIO project. Now we will upload the file system image. Click upload file system image, because we have changed the index.html. Now we'll try to refresh this page again. We can able to see here a red state, green state, and then blue state also coming in. And then here we will try to turn on the green light. So now we have turned on the green light, and then go back to the browser. Now if you refresh this browser, you can able to see by default whenever the page loads, the green is turned on. That is because we have defined the processor function. While this index.html loads, we will try to get the state of each and every pin. If the green pin is turned on, then we are checking this checkbox, green checkbox. Now we will see how to debug if there is some issues. So let's take now we have empty password. So now what I am trying to do is I am trying to build with the empty password. If I try to upload this to click the boot button and then click upload. Now the code is uploaded to the Esp32. Now there is no valid password, so we won't be able to connect to our Wi-Fi. So now we got connecting to and then involve navigation to. Can't connect to the Wi-Fi because we didn't give any password here in this case. In the result section, we can able to see the code associated with the error. In the setup function, we have defined WL connector. So here the WL connector, if you click the WL connector, we can able to see the enum. So here 0 stands for ideal state, no SSD available. If there is 1, there is no valid SSD. If 2, then that is scan completed, and then if this is a 3, then mean that is a successful connection, Wi-Fi connection, and then 4, not success, connection failed. Here we got the 6, that means it is disconnected because there is no valid password, so we got 6 here. By this way we can able to debug something with related to the username and password. Now if there is SSD, it is not even showing up in the connection in the ESP32. So now we will build this code. Now what we are trying to do is, when there is a failure, we are trying to disconnect the Wi-Fi. After that we are trying to scan the Wi-Fi networks. If there is 0, then that means there is no Wi-Fi available. If there is networks found, what are the networks here we can able to see. We need to make sure you are calling this Wi-Fi.disconnect before trying to print the available Wi-Fi connections. Now we will try to upload this code. Now we try to connect to the Invalidation 2. Obviously it will fail because the password is empty. It will wait for some time. Now the result is 6. We have like 19 networks found, and we can able to see each and every network. In this case I have added 10,000 a delay. After it goes through 5, it will try to start printing on top of connecting to, so I have added a lag. By this way you can debug and see whether your SSD is really present or whether that SSD is identifiable by the Esp32. Thanks for watching this video. For more technical videos, subscribe to this channel, and if you find this video helpful, share it with your friends.